One, two, model, training. All right, hello everybody. My name is Gleb, and I have a confession to make. I'm a serial cloud builder. So my cloud journey started back in 2006 at Microsoft when Exchange that I was working for back in the day decided to go from being a boxed product into being cloud first. I learned a lot on this journey on how to take massive services to the worldwide scale. In 2017, I moved back to Russia to help create what's now is a most prominent cloud for that market. And it took us 18 months to launch it. In 2022, when the war started, the original founders decided to break away from Yandex and spin off its most promising businesses into the worldwide scene. And a lot of the top engineering talent decided to go along. So, just 2 years ago, we had just one data center, a few very strong partnerships, long-standing partnerships, one license to a pretty good cloud stack, a team of talented, diversified engineers of about 50. And what we were missing was the winning idea. We've been toying with a few, like sovereign clouds, but things really started going once we decided to focus on powering the AI gold rush that was picking up steam. AI cloud, you say? Well, isn't it just a cloud with a bunch of GPUs? Well, yeah, that's kind of how we thought about it too in the beginning. And it actually worked for the most part back then. So the business was, picking up slowly but steadily. It worked fine for LLMs and especially for the companies with good MLOps and DevOps. But and we would have likely continued like that, continued evolving the platform how it was, and making smaller tweaks here and there, looking for the market fit. But then came the news. The spin-off deal that was going to give us freedom and funds only gave us a limited license to the cloud stack that we had, meaning that we had to rewrite everything from scratch, and we only had a year to do it or go out of business. Well, and you know what? We did it. It took us 12 months, and we were, with one hand, writing the new platform, with the other hand, growing our business on the old platform, learning from it, from this experience. And after this, 9 months, we started moving the clients, and by the 12th month, we moved everybody, and there we were, with our growing business running on the new shiny platform that we had the full expertise in. Well, you say it's a miracle. Well, yeah, in part it's a miracle, but I would also attribute it to adaptability, resilience, and resourcefulness that have grown to be in our DNA. Things kept changing on us so many times since 2022 that drastically and unpredictably, that I would say our life has prepared us for this. So I would have more stories to tell here, but they are more suitable for a coffee break. Well, it was a rough journey, and not to be repeated, but it was indeed a blessing in disguise, I would say. So it was a chance for us to change our mindset and rethink our vision and priorities, modernize the technological stack and decide on our values and what we are optimizing for, and really reflect that in our architecture at all levels. The time pressure was definitely a good cure against the not invented here syndrome that we, really, looked into the open source and saw, and were looking what we could leverage, and deciding to rewrite only by ourselves, only the things that absolutely had to be customized and tailored fit to our cloud. We also had to, have a laser focus on our new mission, and new vision, more streamlined and smaller. So we had to focus and cut the non-essentials. Well, actually, what also helped us to make it happen in just a year was the team that was really experienced in the entire stack. We had experts in data center construction design, in hardware R&D. We have experts in cloud services and platforms. Even we had our own great AI team. And with a few very strong partnerships, like the one we have with NVIDIA, we really could overcome any obstacles that were coming our way in just a few days. Well, AI was booming, was moving really fast, and we wanted to grow fast with it. So with our old platform, we were used to deploying big regions independent from each other, and designed in the traditional way with 3 availability zones deployed to their own data centers that are located closely to each other with good interconnects and whatnot. But we needed to move fast. We wanted to be able to seize more opportunities as they emerge. So we decided to change the tactics here. So now we deploy a greater number, but of smaller regions. And we decided to let go of the idea of having availability zones inside of them. So that allowed us to, on one hand, manage capacity more easily, not breaking up, the precious GPUs into different AZs, but also to enter the new markets faster, because we no longer had to wait till we have signed up, 3 closely located data centers with all the good connectivity in order to move into the new market. So that was really good. And right from the design stage, we set ourselves a goal to architect a system in a way where we could deploy a new region every quarter without compromising on the speed of development of the platform. And ever since the platform went live, we've been able to keep up with this goal. So to move fast, software by itself is not enough. First, the hardware needs to get there and get installed first, and preferably work, one would hope, flawlessly. And that's where having our own hardware R&D team was actually instrumental. And we also have control over manufacturing of the servers in these designs. So we have a one unified OCP-compliant platform that, and servers from it come in one of 2 types of chassis. One is used exclusively for the 8-GPU Delta board wielding servers like H100s in this example. And the other platform, you see it's twice as slim. It can be configured in a myriad of different ways at the factory floor, and even at the data center floor, should they need a rise, but hopefully not. But we really use just 3 SKUs. We configure it to these 3 SKUs. One is flash storage. We call it full flash internally. So it comes with 16 NVMe drives, 2 dual-port NICs, so it can provide a decent bandwidth. And we run 3 types of storage on it. We have 2 types of compute. One is just compute for your CPU-only workloads, like ETL, whatnot. And one is used primarily for inference. So you see it has 4 additional bays for PCI Express GPU cards like L4S. So, yeah. All right. So another aspect of having our own hardware R&D is that we could really focus on operational efficiency. And servers break, you need to be able, the components go out of order. So you need to be able to repair them quickly and easily. And the new servers are really, really heavy. So we heavily invested in making the operational procedures as easy and safe as possible. So everything that can be hot swapped is hot swapped. But if it cannot be, once the server is powered down, you don't even need to take it out of the rack. The necessary parts slide out, you make the replacements, you slide it back in, and off it goes. So there are actually multiple reasons to have to design our own hardware. One of them is predictability and stability of the components that go inside. We learned it the hard way. With off-the-shelf servers, oftentimes you get a new batch, you think it's the same, but it's actually different. Some of the components are different, and you only learn about it once it breaks. With ours, we control it fully. So proprietary OEM firmware is kind of a blocker to be able to run efficiently a big fleet of servers. So we have our own BMCs and BIOSes for the servers, and we base them on the open source stack. For fast deployment, we put the racks together at the factory. We test them as a whole. We put them in big boxes. We ship them. And that way, we're able to really achieve good speeds in rolling out the hardware at the data centers without requiring too many personnel to do that. With third-party hardware, you have to do a lot of extra work to plug it all in the data centers. And last but not least is the thermal power efficiency. So our servers actually take 28% less energy to cool. More on that later. So yeah, 28% if they're deployed to our own data centers, and about 10 to 15% if they're deployed to collocations. So while we can and often do deploy to collocations, we really prefer to go greenfield, meaning to build our own data centers. This way we can leverage the hardware optimizations that we had made in the best possible way, and also you can see they're modular. The modular architecture allows us to build the capacity as we anticipate the demand. So building our own data centers is not cheap, but in the long run it saves us money, and that way we're able to pass on these savings to you. So our data centers are run exclusively on free cooling. That means there are no dedicated air conditioners that cool down the air. We just take the air from the air and we mix it if it's too cold with the warmer air inside the data center. And yeah, that means that the intake air can be up to 40 degrees centigrade, which is like the hot summer day in Europe. Our designs are painstakingly optimized for this, for functioning in these conditions. And actually, like, if it gets warm enough, we are beating, the off-the-shelf competition by those 28%. All right, so the AI boom is indeed impacting the environment. And while we could not reduce our part in this down to absolute zero, I think we were able to offset it quite nicely. So we did that by focusing on cooling and water use efficiency, and also on recycling the heat that we generate. And the heat we produced was used to heat up over 2,000 households in Finland. And this scheme is not anything new to us. Like, we've been running with it for quite some time. And we intend, considering the voracious power appetites of GPUs, it becomes even more relevant now. And we intend to continue using it in the upcoming greenfield deployments. So while we had to rewrite our cloud, our mission remained the same: to make the high-quality infrastructure and services, AI services, available to clients of all types and sizes at reasonable prices and on the terms that fit their needs the best, be it on-demand, reserve, or spot. And this is where our ample past experience with virtualization actually came to help. So by pushing the tenant isolation, like, we definitely built data centers for multiple clients, right? So that's where pushing the tenant isolation to the software layers actually allows us to greatly simplify the hardware. And that, in turn, lets us expand and grow our capacity faster and safer. So that way, for example, we have a single flat underlay IPv6 network in the data center with big GPU clusters. We make them as big as we can make them performing well enough. And multi-tenant storage clusters, which allow for pooling of bandwidth and capacity, which in turn translates to savings. Yeah, so yes, indeed, we do run VMs, but what about overhead, you might ask me, of virtualization? Well, GPU workloads actually tend to be I/O bound, not CPU bound. And for GPU themselves, we pass them right through. For InfiniBand, we use the logical partitioning, and the InfiniBand NICs are also passed straight through. As for VPC network and storage, even with their software implementations that we have, we're able to achieve the line rate speeds at 100G. So even though that's pretty good, we're working closely with NVIDIA to bring the latencies even more down and like soon we'll have the latency for VPC networks be like minimal and line rate everywhere on all scenarios, thanks to the SF square engine that's present in ConnectX and Bluefield NICs. All right, well, here I wanted to put a picture of a sweet AI-generated cake, but our designers didn't let me do it, probably for good. All right, so our old stack was aimed at an average cloud user, which means that we had to have a lot of services. We only had like 10 different databases, and we had serverless compute and all the mumbo jumbo and blackjack. But to succeed in this AI market, we really needed to rethink what we are and what is our offering, what we do and what we do not do, right? So we definitely needed to get rid of the megalomania of, hey, we want to be the cloud for all your needs. No, no, no. We want to be the best cloud for your AI workloads, companion to whatever cloudy concoction that you might already have in your hands. This means we really had to stream down and rationalize what services we're developing and how do they interact with each other. So our system is layered. Each layer is built on top of the other one. Like you can buy compute, but also managed Kubernetes and operator run on top of compute, and also other services run on top of managed Kubernetes. That all means that you can combine all this type of compute consumption and make them share, say, if you want to, the same GPU cluster, the same storage, the same VPC network, and they're all transparently and fluently available there. Then you just VPN this VPC network to whatever other cloud premise you have, and voila, you have the multi-cloud where whatever needs to talk to each other talks to each other. All right, so this is my favorite slide, you can tell. If it gets too boring, just snore at me, okay? All right, so at the base, we have the storage nodes that we produce. Then we have the hardware as a service layer, whose job is really to take care of maintenance of the hardware and make sure that it gets repaired quickly, it gets taken out, is brought back into rotation and whatnot. And it also separates the hardware park that we have into, we call it projects. And the project can be like a specific infra-Kubernetes, a specific Kubernetes service, for example. So actually, you might notice we have two types of Kubernetes here. One is what we call infra-Kubernetes, which we don't give to customers, right? It's just our implementation details, so we stretch it across the entire fabric, well, almost entire. You can see there are some services that we just cannot afford to run on a complex system like Kubernetes, like those that are needed for operational access, like bastions, whatnot, and also some third-party storage systems that I'll talk about later. Also, we have a service that is so heavily optimized to work with the hardware directly and has all the means for that they just run on hardware as a service. But anyway, everything else runs on top of this Kubernetes. We use Cilium for pod and service networks, in case anybody cares. I don't know why. I mean, I know why we run it. I don't know why you would care, but anyway. So you run we run the control planes on top, right in the Kubernetes, because there is no customer code running in those control planes. But for everything that runs the customer code, it's unsafe to run it this way, we think. So we run it on top of the virtualized stack. And it looks like this. So we have KubeVirt, which is the open source stack that we are really thankful to. It was able to get us up and running in just a matter of a couple of months. So we use it to manipulate VMs as the native, not native, like CRDs inside the Kubernetes. We had to heavily customize it, but it was really a great help. Back in 2017, we could not do it in the old cloud, right? It's all new stuff. So for the VPC, we had to write our own. The stock CNIs did not work for us. We tried many. But we still based it, of course, on the open source where we could. So we used OVS, because OpenVSwitch, because it's easily offloadable, like it's de facto standard, easily offloadable to Mellanox cards, NVIDIA cards. And we used, but it doesn't allow you to do complex custom logic. So for all the custom logic, like netting, load balancers, whatnot, we used the Cisco VPP, or FDIO VPP, vector packet processing engine, which is what our virtual gateways are based on. So storage platform. As I said before, we have a full stack expertise, storage notwithstanding. So we have our own storage. It's been in development for over 5 years for file store and even longer for the base platform. And yeah, it's a really cool system, almost infinitely scalable, kind of similar to Spanner in the underlying architecture for the database itself. So yeah, the compute is built on top of these 3 services, and then we have managed Kubernetes that's built on top of compute. These are the clusters, also runs Cilium, but it's different, right? It runs on top of VPCs, so it provides the tenant level isolation. You run it in the private address space that you control so that you can VPN easily to wherever you want to VPN. You control the IP addresses there. So it's IPv4. And underlying network is IPv6 for us. And the managed Kubernetes, yeah, you can just provision one for yourself with a mouse click, and you can combine the compute and GPU workloads in it just the same. On top of it, we built our own services of the higher level, like all the ML platform stuff, AI Studio that we'll briefly mention today, and this operator, which is our version of the managed Slurm. There will be actually a separate talk on this, and please come and listen if you're interested, and you're probably interested. Right, so that's the stack. All right. Didn't hear any snoring. I don't know, was it interesting? All right, so one thing is vision and another is execution. It's not like we had a crystal ball that we could take a sneak peek at and see what we need to do to deliver a cloud in a year. And it's not like anyone in the industry walked in the same shoes. Like nobody had to develop the cloud in a year, right? So we were kind of on our own here with making our own mistakes and reaching our own successes. So we really had to learn from the market what it needs, and what are its realities and how they're different from what everyone was anticipating. And we needed to learn so that we would not only be ready to change with it, we also needed to learn so that we can anticipate where it's taking us. So we had a good starting point, but yeah, we needed to walk at this road. Oh, sorry, it was a little too sudden. All right, so after my glorious bragging and shameless pep talk, you're probably hungry for some gory fail stories. Well, Levon will talk more about them after break, but I couldn't help myself stealing some of his bread and tell you about the 2 pitfalls that are especially dear to my heart. Well, we used to live in the world of VMs, right? Selling compute hours, and that worked in the past. However, if you take AI, especially AI training, people really don't want to buy compute hours. They want to buy good compute hours. And what good means in this case is the hours that directly contribute to the progress of the model training. Training is done in clusters, and clusters are getting bigger. And a failure of any given server, for whatever reason, it actually impedes the progress of training. It breaks it. You need to start it over again. Well, that's where checkpointing helps, right? And checkpointing is great, and you probably have to do it often. And the bigger your cluster is, the more often you need to do it. This was back maybe like a year ago. And a year ago, asynchronous checkpointing was not a common thing, right? There were some training libraries that didn't have it integrated, so it was, it was a problem. And customers really don't want to checkpoint. They don't want to pay for the time they're checkpointing, especially synchronously, because they're not running training at that time. So they actually want this hardware to not break. And even if it breaks, they want it to be repaired with the minimal intervention from their side. And this is why we're heavily investing and now integrating the auto-healing across the entire stack, right? So it comes from the depths of monitoring the hardware, and you can we will be perfecting it as we go to make it even predictive. So it starts from hardware, goes through compute. So if you consume compute, we'll be sending the maintenance events. If you're consuming Kubernetes, Kubernetes will be integrated with that as well. And if we talk separator, there will be even a more automagical integration at that level. So the higher level of compute you use, the more automagical it will be for you. But if you use lower layers, you'll see benefit from it as well. Oh, Sorry, that was a very empty slide, and nobody told me. All right, so actually, it's not that empty. Yeah, pretty much everything I just said. All right, so auto-healing aside, I mean, auto-healing is great, but how do we make hardware break less often? Well, since we control our manufacturing, we did a curious thing. So we brought mini data centers over onto the factory floors. So we built a small data center with the plus 35 degrees centigrade aging rooms in which we make our racks sweat and run the comprehensive set of tests. And if any of them does anything wonky, it stays on the factory floor, and we figure out what's going on with it. We don't ship it. So after shipping and installing them in the data center, we run again the same set of comprehensive tests. And if at the factory floor these tests could fail about, give or take on a bad day, maybe 5% of the park. After installation, about another 2% can be failing for various reasons. So we replace those servers and replace them with the spares. So we deliver our GPU clusters, we use InfiniBand, in pods, right, which are then connected up to the higher levels of network. So that's the first unit that makes sense to test together in the network sense. So once it's ready, we run another set of tests that is supposed to exhaustively test the InfiniBand fabric. That's really like kilometers of different wires. A lot of things can go wrong there. Once that's done, we actually ask our AI team to come and run on this capacity. And we hope it's working fine, but sometimes it doesn't. Yeah, my colleague is smiling. I mean, he knows how many times it failed. Hopefully it's failing now less, but there are some issues that cannot be found by a comprehensive test, and only you need to run the customer-like workloads to find issues. We've had stories. If you want to hear the stories, come find me at the coffee break. So, and only then does this hardware actually get to you. We bring it to capacity, and now it's allocatable to the customer's clusters. So a lot of things can actually break in the servers, right? Like we've had all components, starting from data centers, voltage regulators, to cooling, like not being fast enough to ramp up the speeds, to power modules in the servers. And GPUs are not immune to that. They sometimes fail too, but more often than not, they actually can be recovered by just resetting, rebooting the server. But by then, you would already have a spare VM or Kubernetes worker joining your cluster. So that's taken care of by our automation. All right, so another painful lesson that we hit was with just how voracious in terms of I/O some of the AI workloads could be. So, the storage we had worked quite well for, it worked great for the general purpose cloud. For the LLM kind of workloads training, it worked just fine too. However, when the multi-modal models came, and then, video workloads, high-definition video, now VR, all that really ramped up demand on the storage, and we were not prepared for that. Like, we knew we need to speed this up, but we didn't expect it to come so quickly. Like, we were very busy with rewriting the cloud, right? And yeah, it was quite hard. Another realization was that customers sometimes have habits we did not anticipate. Like, for us, it didn't make sense to combine, like, intermix in one file system your training models, your checkpoints, your dev environment, your logs, and your models. Like, why would you do it? Well, it turns out it's convenient, and customers do that, and in some clouds, some storages behave well under this kind of workload. But and while we optimized for some of these workloads, when they're so intermixed, it really caused our storage some misdigestion, so to say. So some of the optimizations we had put in place were actually falling short of expectations. So what did we do? Well, it was hard, but we reacted fast, and our wonderful storage team managed to stay on top. And just within half a year, really, shard and scale and cache everything they safely could. So they boosted the single storage throughput on some scenarios to 10 gigabytes per second. and which is above some of the guidelines. And right now, I checked this morning, the cluster is sometimes serving half a gigabyte per second of data ready for further expansion. Like the system is pretty infinitely scalable. However, in this race, we realized that the demand, especially for I/O in this rapidly changing world, can take very sharp turns, and it can beat even pretty brave anticipations that NVIDIA, for example, published in their docs for cloud providers. So yeah, we're basically afraid that after another sharp turn, we will not be able to keep up. So that's why we decided to supplement our storage offering with some of the third-party options as well, while we continue working on ours, and it will continue scaling and get faster. All right, so how do we summarize all this? Well, we believe that high-quality AI inference services should be available to everybody. Come small, and we will support you through your growth. Come big, and we will be able to get you running optimally on our cloud in no time. We can deliver. We have a team you can trust, whose expertise, adaptability, and grit were instrumental to get us where we are today, and they will be key to help us deliver on our very bold goals. And yeah, AI clouds are hard, but and unpredictable. I would say the industry is booming, and it's a moving target. But I think we got it. And nonetheless, I promise we'll keep learning always.
Three.
Yeah,
so I didn't interrupt Gleb because I think his talk was very interesting. We have not much time, but let's have one question for Gleb, and then coffee break. I think. And please,
I think my mic is out.
You will get microphone from the other side. Yes. Please introduce yourself. No, you are recorded. You have to
shout. I don't think I'm live anymore.
All right, so I have to speak. That's fine. So, yeah, thank you very much. First of all, Gleb, my name is Gleb as well, by the way. So, yeah, it was very nice diagrams and all this kind of stuff look quite familiar. I have a technical question, if you can answer it, like just give a little bit of insight on how this is done. As you mentioned KubeVirt, I guess there's a lot of virtualization going on, and now, if GPUs could be virtualized quite easily, I guess the bigger problem is to virtualize NICs, right? Since you mentioned that you have this 400 gigabytes InfiniBand. So I was just wondering, what kind of stack have you used to virtualize InfiniBand?
Oh, actually, the answer is simple. And I think I said it, but maybe I didn't make it clear enough. So GPUs, we don't virtualize, we pass them through, right? So they're PCI Express devices that we pass through, and they're consumed, I guess, like VFA or PCI or something like this in the maybe not in the guests. The same goes for the InfiniBand NICs as well. We don't we use SRIV to break them up in parts, but since we don't really have to do it. Like every single GPU has its own NIC that it works with. It sits on the same PCI Express switch with it. So we actually take a part of it, like VF, and throw it as a PCI Express device into the VM. And KubeVirt supports pass-through, so that's not an issue. So we don't virtualize neither. So, and that I think is important for the GPU cloud. We don't do vGPUs like there is. We didn't see too much demand for it yet. Thank you.
Thank you, Gleb.
Please, sorry for running over time. I mean, if you have more questions, find me in the coffee break. Thank you.
Thank you.